Next example, we have this rational function, which looks a lot ickier than the one we just did, but it's okay. We're going to approach it the same exact way. So we're going to take our denominator, set it equal to 0 to find our restricted values. Here we would be looking for a product of -10 and a sum of 3, which means that we need x plus 5 and x minus 2 equal to 0. And we find that our restricted values are x equal to -5, x equal to 2. So when we're doing our domain, negative infinity on the left, positive infinity on the right, -5 close to the negative, positive 2 close to the positive infinity. Remember that those are our restricted values, so we cannot use them. And when we find our domain, starting on the left, it's going to be negative infinity to -5, union, -5 to 2, union 2 to infinity. And there's our domain in interval notation. In simplified form, we know that the bottom factors into x plus 5, x minus 2. But we need to see what the numerator factors into. So if we look at our numerator, we have 2x squared minus 12x plus 16. Start by taking out the GCF. Our GCF, we start with the smallest number, 2. 2 does go into 12 and 16. So we know our GCF is going to include a 2. Ask yourself if it includes an x. Does every term have an x to contribute? Because the 16 does not have an x to give, our GCF is only 2. So we're going to have x squared, because 2 divided by 2 is 1, minus 12 divided by 2 gets us 6x, plus, and 16 divided by 2 gets us 8. Looking inside, we need a product of 8 with a sum of -6, which means that this will factor into x minus 4 times x minus 2. So rewrite our numerator, 2 times x minus 4 times x minus 2. From here you can tell that a factor shows up in both top and bottom. So get rid of the x minus 2's. And our simplified form is 2 times x minus 4 all over x plus 5. Remember, from this point forward, pay attention to your simplified form. Our vertical asymptotes are what's left in our denominator. So we're going to take our x plus 5 equal to 0, and we get x equal to -5 is our vertical asymptote. Looking for a whole, it's what did we cancel? Because we canceled something this time, the x minus 2, we set it equal to 0, and we have x equal to 2 is where our whole is. But they want the coordinates. Remember, the coordinates of the whole, we plug in into the simplified form. So we're going to have 2 times, plugging in 2 for the whole, minus 4 all over. So of x plus 5, we're going to have 2 plus 5. Up top, we get 2 times -2. all over 7, negative 4/7, which means the coordinate of the whole is going to be 2, comma, negative 4/7. Rewrite it so it's a little bit easier to see. Okay. Horizontal asymptotes are slant asymptotes. Remember, we're looking at the simplified form. We have polynomials in top and bottom. The top is factored form. Bottom is standard, but they both have a degree of 1. So degree of the numerator equals 1. The degree of the denominator, again, equals 1. And these guys are equal. Remember, when the degree of the numerator and degree of the denominator are equal, we're going to have a horizontal asymptote of a over b, which is our leading coefficients. Leading coefficient of the numerator is 2. Leading coefficient of the denominator is 1. So we have y equal to 2, since we simplify, as our horizontal asymptote. Next, we need to find our asymptotes. Our y-intercept, we plug in x equals 0, again into our simplified version. So I'm going to have 2 times 0 minus 4 all over 0 plus 5. I have 2 times negative 4 up top all over 5, which gets me negative 8/5. The ordered pair we just found is 0, which we plugged in for x, negative 8/5. To find our x-intercept, remember we're going to set the numerator equal to 0. So we're going to take 2 times x minus 4 equal to 0. If we take this separate, 2 equal to 0, that's never going to happen, so we don't need to worry about it. It didn't have an x involved. X equal to 4 tells us that we get, x minus 4 tells us that we get x equal to 4. Our x-intercept is 4, 0, because we plugged in 0 for y. Now that we've done all this work, we can go ahead and graph. Here, my coordinate plane does not have any axes, so I'm going to start by labeling my x and y axes. After I do that step, I need to graph my vertical asymptotes, if any exist. I have a vertical asymptote at x equal to negative 5. So I'm going to go 1, 2, 3, 4, 5 to the left and do a dashed line, vertical, and label it x equal to negative 5. We have a horizontal asymptote of 2, y equal to 2. So I'm going to go ahead and graph that. I go up 2 and across. So I have y equal to 2 as my horizontal asymptote. Then I found 3 ordered pairs already. I have my x-intercept, my y-intercept, and then the whole. My x-intercept, I'm going to start with, it's the nicest one. It is 4, 0. 1, 2, 3, 4, 0. I have 0, -8/5. So that's -1 3/5. So not quite 2. There's my y-intercept. And I have a hole at 2, -4/7. When you're drawing the hole, you're going to make sure that you have an open circle. So we're going to go to 2. We're going to drop down. It's not quite to 1. It's -4/7. It's almost kind of like a half. We're going to draw an open circle. And yes, I know that is exaggerated. It's way bigger than it probably would be, but we need to be able to see it. And it's an open circle because that's where we have a hole in our graph. Now that we have plotted all of our intercepts and our asymptotes, we can find some additional ordered pairs. We go on either side of our vertical asymptotes. So vertical asymptote of x equal to -5, we need to find out what's happening at x equal to -6. And then to the right would be x equal to -4. And then if we need to plug in more points, we will. Remember, we're going into the simplified version. So I'm going to have 2 times -6 minus 4 all over -6 plus 5. If I simplify down, I have 2 times -10 all over -1, and this winds up being 20. So I have -6, comma 20. On -4, we would have 2 times -4 minus 4, plugging into the simplified version, all over -4 plus 5. This gets me 2 times -8 all over 1, which winds up being -16. I have the ordered pair -4, -16. Okay, so it's safe to say on the right side of the graph, if we're going towards infinity on the x, we're going to keep coming up and get closer. When you're drawing this, make sure that you do not color through that circle, that hole. And my graph doesn't go to -16, but I can still connect the ordered pairs that I have, the intercepts, and I know that my graph is going to take a turn and fall rapidly. Okay. On the left-hand side, we know -6 has 20, which is like way, way, way up here. So we know it's getting really positive when we get closer to x equal -5. Let's plug in another value over on the left just so we can make sure it's getting close to 2. So let's see, 5, 6, 7, 8, 9, 10. Let's see what happens at x equal to -10, just because we can. We would have 2 times -10 minus 4 all over -10 plus 5, which means that we have 2 times -14 all over 5. We get -28 over 5. So we have the ordered pair, -10, -28. Oh, I dropped a sign. -5 on the bottom, which means positive 28 over 5. Sorry about that. And 28 over 5 is 5 3/5. So between 5 and 6. So go to where -10 is. We're already at 2, 3, 4, 5. So it's about here. Which means when I connect on the left-hand side, it's going to shoot up into the air really quick as we approach the x equal -5, and then it's going to slowly come down towards my horizontal asymptote of y equal to 2.